Hello everybody, my name's Chris and I'm from Tandem. For those of you that haven't met us before, we're building a bank that's on the customer side. It's a big honour to be here in this Ticketmaster office. I remember doing some work for Ticketmaster about 15 years ago. Does anyone remember using WAP? So I was on this project for Ticketmaster and they decided they would sell tickets using WAP. This was in Sydney. It was a great idea, very innovative, but unfortunately it turned out people didn't want to buy tickets using WAP.
Why?
Who knows? I wasn't on it that long. Okay, so I've been with Tandem for about 2 years now, and I've seen a whole load of change both in terms of Agile and DevOps. So I wanted to share some of my experiences with you. I'll be talking about the changes I've seen to our environments, how we've built code, how we've released it, how we monitor it once it's in production, how we've structured the teams, how we test everything, and I guess also how we've improved the communication in our company just to facilitate all of that. So when I joined Tandem, I thought we were doing Agile. I thought we were doing everything right. We had all of this. We had a sprint planning, sprint backlog, execution, sprint reviews, retrospectives, but unfortunately we were missing the most important thing on this diagram, and that was the potentially shippable increment. What we had at the end of each of our 2-week sprints was something that was ready for test. It wasn't ready for production. And to understand why that was, you really need to understand what was going on in our environments. So I got from prod, we had the prod environment, which was managed by ops. We had the UAT environment, which was owned by the QAs. And we had the engineers working away in dev. Now you can see that prod had a full core banking platform. UAT had a full core banking platform, but unfortunately the engineers, all they had to work with was mocks. So you'd get them working away building these systems for 2 weeks, and at the end of the 2 weeks, they would throw it over the fence to the QAs and just pray that it worked. It almost never worked because a core banking platform is a very dynamic thing, and mocks can only give you so much. So if you had a good run through this, it would be 2 weeks, 2 weeks, 2 weeks. You almost never had a good run. And what would happen after the first month is it would go back to the beginning for another 1-month journey and finally the 2 weeks to production. So a lot of these changes, they took 10 weeks to get through to production. It was just unacceptable. Another problem that we had with our environments were the servers themselves. Are people familiar with Snowflake servers? So Snowflake servers, like snowflakes, they all look the same from afar. But once you inspect them closely, you'll find subtle differences. And these led to problems like systems working in dev, working in UAT, and then mysteriously breaking in production. This happened all the time. Now, the way that we fix this is through automation. If you're going in and manually configuring servers, you're going to forget things, you're going to make mistakes, and it's time consuming. So to get around that, we just had to automate as much as we could, using infrastructure as code to actually provision the environments, configuration management to put the prerequisites on, and Octopus deploy to deploy our systems. Another problem we had here was the ownership of the environments. If you have ops starting and living in prod, they're not going to understand how to support the systems that are coming through. And if you have engineers only taking responsibility for the dev environment, they're not really going to build robust systems. The way you get engineers to build robust systems is to get them to support what's in production. If they're getting calls at 3 a.m. in the morning, they're going to change systems and write them in a way that they're not going to break. So the way we fixed this problem was to get a core banking platform for the engineers. So we introduced test. It was no longer mocked, and it meant in that 2-week sprint, engineers had access to everything that they needed to build their deliverables. So what happened at the end of the 2 weeks was they were delivering software that worked. So what was, a 2-week process sending software back into the sprints was something that worked. So we got it down from about 6 weeks to a bit over 2 weeks. We also got QAs to start doing QA in the sprints themselves. So this concept of shifting everything to the left is something we try and do all over the place. And also getting the people in ops involved a lot earlier. So what was going on in the sprints and after the sprints was our initial focus. But we also had to look at what was coming into the sprints. So initially we had this problem that there was a whole big long period of big upfront design. What was coming from the designers was high fidelity, full detailed screenshots of everything. That would go to the products team, they would write the features. And so by the time that it got into the actual sprints, we'd already lost a couple of months. So what we tried to do is, with designers and the products team, try and get them into this iterative approach and try and get everybody involved in the sprints and try and do something a bit more like the bottom. Another thing that's changed quite a lot over the time I've been at Tandem is the structure of the teams and the names of the teams. When I joined, the teams were named after colours. Doesn't seem so bad, a little bit abstract. You've got the idea that our teams last longer than features, so call them colours. There were quite a few problems with this. The main one was, with so many new joiners coming to a startup, nobody had any idea what the teams were working on. You had to do, and once you did learn, you constantly had to do this mental mapping exercise to remember which team was looking at which features. Another issue with this was when we presented the progress of the teams to senior management, we had to use RAG status. So you would end up with the red team is green, the orange team is green, the blue team is orange. It was crazy. Names are really powerful things. For a while we had a project called Horse. Within a week, that team were wearing horse masks, putting pictures of horses all over the office and referring to the office as the stables. So what we changed was to basically call the teams by what they do. Straight away, everybody could understand what was going on. The data team was responsible for the data warehouse. The originations team made it possible to open products. The public web team looked after the public website. Login and registration speaks for itself, and so does account aggregation, if you know what that means. It was good, it was a big step forward, but it wasn't the final change that we made. There was a problem with this structure because if you had a feature or you found a bug with a feature and it didn't fall into one of these 5 neat buckets, you didn't know who to speak to. You didn't know who to assign the ticket to. So, and the other problem was we've got iOS, Android website. With iOS and Android, with no dedicated team, you don't have full ownership of the platform. So these features would be fine, but as a whole, it didn't work too well and the quality wasn't great. So the final thing that we changed was to introduce component teams. So now it looks a bit more like this. I think, feature teams are great. Component teams are okay. I think something's going to work for some companies and others. Maybe if you're a startup, it's not a bad idea to start with component teams because it gives you that full ownership of your product. Another thing that we've had to improve is the way we release the software. Initially, we batched it up per platform. So the public website went out at its own pace, so did the analytics platform, and so did the digital platform. This worked fine for the public website and the analytics platform because these were just one team each for those platforms. But where it got complicated was with the digital platform. It was made up of the iOS team, the Android team, and a number of back-end teams. Our fear was if we didn't release the software from all of these teams at once, you'd have compatibility issues. We didn't really need to worry about this as much as we did because the back-end engineers are versioning the APIs, we're using semantic versioning, and the teams themselves are aware of the interdependencies. So what we had to change was rather than making all of these teams have to release code at once, was to let them go at their own pace. So moving away from only being as fast as your slowest team to something like this. So you didn't have that dependencies across the teams anymore. And when we introduced this change, we got the releases down from a bit over 2 weeks to about 3 a week because you're no longer batching them up. And I think, as always, you should avoid big bang releases, and that's what we were creating by making all of the teams release their changes at once. Are people familiar with the testing pyramid? We had what was essentially an upside-down testing pyramid. We had way too much exploratory testing going on and not enough test automation. So this is something that we've just slowly improved over the last couple of years. For those of you that don't know this, unit testing is essentially testing the business logic within a component. That's where TDD is usually used. Integration testing is testing systems against other systems and making sure that they can speak to each other. Acceptance testing is making sure that your systems meet your business requirements and is acceptable for delivery. And finally, you've got exploratory testing, which is people actually using your apps or your website and making sure it behaves as it should. Exploratory testing is necessary, but it's also very bad because it doesn't scale. The reason it doesn't scale is because the more features you build and the more complex your apps get, the more edge cases you have to test. So as you get over more and more time, it becomes an impossible task. Your regression tests get massive to the point where you just can't do it anymore. So that's why you need to really focus on the automated tests down the bottom. Now, we spoke before about the build server and the hat of shame. That's this here. So we've got three, I guess, core components to our continuous integration and continuous deployment pipeline. We've got Bitbucket, which is where the code lives. We've got TeamCity, which builds the code. And finally, we use Octopus Deploy to get the code into the environments. In Git, you've got a few different workflows that you can use. We've eventually settled with trunk-based development. It's a really good approach to continuous delivery. Basically, engineers put their changes into feature branches. You do code reviews to get that into your master branch. And you basically avoid having long-lived branches. If you've got long-lived branches, then you have this impossible merge task to deal with. What you do is you constantly merge into master, and the idea is whatever's in master, you can release to production anytime. Even if you've got a half-finished feature, you should still merge it into master and use feature flags to turn it off until it's ready. Once a change goes into Bitbucket, that's where TeamCity comes in. It detects the change. First, it will compile your code. Next, it does some static analysis to make sure your code is industry standard. It does some unit tests, so make sure the change to that system works by itself. And finally, it'll put it into the dev environment and test it against the components that it lives with. If that all works, then the acceptance test will kick in, and that's when you know that your system is actually doing what the business wants. Finally, we put that into the test environment and do the same tests again against the core banking platform. If everything makes it to the end fine, then we know that we've got something that's ready for production. The only thing that's stopping us from releasing it straight to production now is we don't have enough test coverage. Once we have enough acceptance tests covering all of our features, then we can get our releases from a few a week to a few a day. Once you've got your changes into production, that's not the end of your journey. You need to make sure that it's all working fine. The situation that we're trying to avoid is having one of our customers having a problem with our app or our website, ringing up our customer service agents and having them tell us what's wrong. The way we've solved this problem is with a few different products from New Relic. First of all, we use their application performance monitoring. It tells us whether the systems are throwing errors or not, and also how fast or slow they are. We use their infrastructure monitoring to make sure that our servers are at the right capacity, make sure there's no issues with CPU, memory, networking, that sort of thing. And finally, they've got a product which is great called Synthetic Journeys. This basically simulates a user. It's a virtual user interacting with your app or your website every 5 minutes. So you hope that your virtual user is going to catch the problem before your real customers do. If it does find a problem, we get an alert in HipChat. HipChat's been a really great introduction to our company. Before that, we were using Skype. Skype was fine for one-to-one communication, but HipChat, you can create rooms anytime you need, pull people into rooms. We've got a prod issues room in HipChat that everybody gets alerted to. So straight away, whenever there's a problem in production, everybody can see it and we can fix it straight away. The last thing in this diagram is Elk. It basically manages our application logs. It's comprised of 3 different systems. You've got Elasticsearch, which is a NoSQL database and really effective at searching for things. You've got Logstash in there, which is responsible for going and collecting all of the application logs from our different servers. And finally, you've got Kibana, which is your dashboard where you can go in and search for your logs. And so the general process for us is, if we get an alert in HipChat, New Relic will tell us exactly what the problem is. We then go into Kibana, search for the problem, diagnose it, and then hotfix the environment. Now, communication is constantly evolving in the way that we do things. One really important thing was the product roadmap. Initially, we didn't have this. Without a product roadmap, you don't know what your MVP is. If you don't have a minimum viable product defined, then you try and do too many things at once. If you're trying to do too many things at once, then you end up delivering nothing. That was a problem for a while until this came out. Once it was introduced and distributed to everybody in the company, it was very clear what we needed to do, and any arguments about what we had to deliver were resolved by this. Scrum of Scrums was a really important introduction as well as the number of our Scrum teams grew. It was, I guess, predominantly just to resolve dependencies between the teams, but it was also really important because half our engineering team is in Poland. And when half the team's in Poland, you really need to do as much communication as you can. And that's where we really had to beef up our co-location. So having most of our engineers in Poland, but our designers and product owners in London was a real problem. It was a real challenge. So the way we've got around that is to do a lot of trips to Poland and have the Polish guys come to London a lot more often. Finally, our sprint reviews really evolved over the 2 years that I've been at Tandem. What was initially a demo, not a review, and it was a demo of something that wasn't ready for production. It was a demo for something that was ready for test. So it just wasn't that interesting. The demo became more interesting once it was actually features that were done, but also once we talked about what was coming next, and also just sharing the number of bugs going down, seeing the quality improve, and also the test automation coverage. I guess I'd just like to finish off by saying that there's no one thing or no one change that we made that fixed everything. It was hundreds and hundreds of small things. You just need to be constantly improving, because if you're not improving, other companies out there are, and then you're going backwards. Thank you.